Hi, Lim Zhi Hao. Hi, Goh Wei Jie. Hi, I'm Benjamin. Hello, I'm Jeff. Hi, I'm Brayden, and we are G6T2.
Good morning, profs. We are Team 2 and we are here today to present to you our project on 7-Eleven's warehouse storage process of chilled food products. Without further ado, let's get started. To give you a little more background on our project, the team's aim is to improve 7-Eleven's warehouse storage process, specifically for chilled food products. We are also introducing two new IoT solutions to further improve our 2B model. These are the highlights of our presentation. First, we'll be talking about our workflow model of the 2B process. Next, we'll jump into the first IoT, which is storage robots. Afterwards, we will be talking about improving our current temperature sensors into IoT temperature sensors. Lastly, we'll end off the presentation with some challenges of our implementations and suggestions for a non-IoT technology idea for our 2B process. First, we will be starting with our current 2B model of the storage of chilled food products. The stakeholders involved are the delivery man, warehouse manager, logistics clerk, and warehouse packer. The systems implemented in this process are the delivery management system, which encapsulate all data from order and delivery transactions, and the warehouse management system, which automatically assigns storage location to accepted products based on the storage requirements. Our overall business process can be broken down into three main sections, beginning with the receiver of weekly deliveries, followed by quality checks to ensure we push out only products of the best quality, and finally, ending the process off with successful storage of food products.
First, we'll be taking a look at the receiving of delivery. Upon receiving the weekly delivery of chilled food products at 7-Eleven's warehouse, the logistics clerk would obtain the car plate number from the delivery man and input it into the DMS to retrieve the delivery invoice corresponding to that truck. The logistics clerk then proceeds to check the temperature sensor on the truck and assesses whether it has passed the temperature check. To pass this, the temperature must not have exceeded 5 degrees of the product's recommended storage temperature. If the truck's temperature is found to have failed this check, the delivery and its invoice will be rejected within the DMS, and the converse if it passes. Moving on, we will perform more thorough inspections to further ensure the quality of the food products. Warehouse packers will randomly pick and open one box from the pallet to conduct this check, after which they will proceed to check if the product has exceeded its expiry date. Any products which fail to pass these checks will first be escalated to the warehouse manager and subsequently discarded after it has been rejected in the DMS. As for products which do pass, the warehouse packer will proceed to confirm these pallets as successful deliveries within the DMS. Lastly, warehouse packer would scan the barcode to retrieve storage location assigned by the WMS. They will then move the food products to the assigned chiller. Once successfully stored, they will confirm the successful storage of food products in the WMS. The WMS will then notify the warehouse manager of the successful storage of food products.
Our first IoT recommendation would be to use automatic storage robots. These automatic storage robots would ideally be able to replace the warehouse packers in their entirety. They will be alerted when incoming delivery arrives to the warehouse and are able to perform their tasks much faster than the warehouse packers, seeing as they are mechanically stronger and immune to fatigue. They will also be able to eliminate the factor of human errors and overall function more efficiently. With storage robots replacing the warehouse packers, the time taken for robots to store food products is projected at 31 minutes, approximately half the time taken as compared to the human warehouse packer. Another recommendation would be to use IoT in temperature sensors. With IoT-enabled temperature sensors, we will be able to interact with DMS, and this allows for live monitoring and logging of truck temperatures. DMS can then be used to communicate with the driver or employees at 7-Eleven's warehouse, such as the logistics clerk. Hence, immediate action can be taken in the event of irregularities in temperature readings. In the current process without IoT, the truck makes its way to the warehouse. Then, the delivery man notifies the logistics clerk of their car plate number and the truck's arrival. The logistics clerk then retrieves the delivery invoice and checks the temperature sensor physically. However, with IoT-enabled temperature sensors, DMS will be able to monitor storage temperatures real-time, and drivers will be alerted by DMS should any discrepancy occurs. They would then be able to attempt to rectify the situation and possibly prevent food wastage and continue delivery. If they are still unable to do so, the order may be rejected by the logistics clerk, and the delivery man may return the goods to the supplier.
So I'll now begin the conclusion of our project. So overall, the main improvements of implementing the IoT temperature sensors and storage robot would be removing the need for manual temperature checks at the warehouse. As a result of this, efficiency of the process would be significantly improved. However, the efficiency of the process of quality checks would remain unchanged even with the addition of IoT, as it does not serve this purpose. These improvements, in the form of robots and IoT temperature sensors, are difficult to manufacture and have state-of-the-art software. Hence, they would cost a hefty sum of money. In addition, maintenance of these IoTs might cost a lot, as they would require constant maintenance from a high-skilled professional and ordering of specific parts for repairs. In order to use these IoTs, 7-Eleven would have to implement new systems and make big changes in the infrastructure in order to ensure that these IoTs would run smoothly. Changing of infrastructure not only costs significant time and money, but also a huge risk, as these IoT might not achieve the expected results as planned. As part of our goal of making the processes more efficient, we have decided to incorporate the use of tablets, which is a non-IoT improvement. The tablet, which is connected to the WMS and DMS systems, will make input and receiving of data much easier. Now, as most workers are familiar with the use of smartphones and tablets, minimal training will be required to get them up to speed on how to use the new tablets. Lastly, since tablets are also fairly inexpensive, they are very cost-effective for the value that they would provide to improving the efficiency of the process. And with that, we would like to thank you for listening to our presentation and are now open to accepting and clarifying any doubts that you may have.